Hey, third grade. So, after reviewing our last experiment with my class, where we took a look at the effects of evaporation, or the effects that a lid of a jar would have on the water in a container being evaporated, we decided that we didn't really like how that experiment went. The one thing that we agreed on was that it wasn't very clear how much water was actually evaporated because we put a paper towel in there which absorbed some of that water. So, the one thing that we wanted to retry, and that's what we're going to do today, is filling up a container with 30 milliliters of water, just like we did, but this time without a paper towel. And we are going to cover it with a lid and check back on it after a full 24 hours, and we'll see if any water was evaporated at all. So I have here my jar, and I have 30 milliliters of water, and we are just going to fill it up. All right, and I'm going to put the lid right on top of that. And that is airtight. Okay, so double check. An airtight lid. And we are going to just leave this out for 24 hours. And then, just like our last experiment, we'll pull that water back out of there. And we'll see if we actually lose any water from evaporation with our lid on. So this will be a little retry of our last experiment. Hey, third grade. So we are now going to take a look at that closed jar that we filled up with 30 milliliters of water. This is our previous experiment that we did, but we had a paper towel in the jars last time. This time we are getting rid of the paper towel to really find out if any water is evaporating with a lid on. So we'll get that lid off of there. I have my syringe here once again, and we are just going to pull that water right out of there, and hopefully we'll see 30 milliliters here. We're going to try to get all of it. All right, now of course this is filled up way too much. All of that is the air, but fortunately for us, the air is less dense than the water, so it's floating up at the top, and we can just kind of push it on up there, and hopefully we can do it and not spill it all. Ooh, caught it. We are very, very close to our 30 milliliter mark. But this is much better than when we had the paper towel. We lost 8 milliliters then. And I do not think that was a representation of the evaporation process in a closed container. I think that this is a much better representation of that. And we can really see that when a container is closed, the liquid that is inside of it will not evaporate. So much more conclusive experiment today. All right, hey, third grade. So today we are now going to start a new experiment. In review of our last experiment, we concluded that for water to evaporate, the water needs to have an open air flow. It needs to make contact with the air. We learned that water will not evaporate in a closed container. It has nowhere to go. So today we want to take a look at something new. We want to look at the effects that the temperature of a location has on the amount of evaporation. All right, so in order for us to test this, what we are going to do is fill up 4 jars, 4 equal sized jars. Here's what they're going to look like. I already have 2 filled up. Here's our third and our fourth one. Right here, we have it empty. I kept it empty so that I could show you that we are filling them up with exactly 50 milliliters of water each. All right, so each jar will be filled with exactly 50 milliliters of water. And I'm using all of the same jars and the same amount of water and the same temperature of water because we want as few variables as possible. We don't want things to be different and then have an effect on our experiment. So we're going to try to eliminate that opportunity and really be able to test what it is that we want to find out, which is how will the temperature of a location affect the evaporation of water. All right. So when we were picking our 4 different locations, I wanted to focus on 4 areas that should all have very different temperatures. Now, I'm going to have to edit in here the different temperatures using a thermometer of each location because the thermometer I have doesn't read right away. It has to sit there for a little while. So we are going to be measuring the temperature of each location over the next 3 days. But this will be a 3-day experiment. We are going to put our 4 jars filled with 50 milliliters of water in 4 different locations. And after 3 days, we are going to use our syringe and pull out all of the water that's in those jars and find out how much water was evaporated in each location. All right, so our first location, we're going to take this open jar with 50 milliliters of water, and I'm going to put it right up there above my stove. Now, it's going to be in a closed cabinet, so think about that when we talk about airflow, right? It'll be in a closed cabinet, but it will be in a pretty warm area since it's above my stove. So, right in here, we're going to just place our jar, and it is going to be, hopefully, it will be safe right there. I'm going to try my best not to knock over any of these jars. Another location I was thinking, I wanted to get it a little bit cooler, right? So our other option, and I just recently learned that you can't flip the camera around on a phone, so please bear with me. It's going to look awkward the way I'm turning this whole thing around. But our other option is we are going to place it right here on my countertop. And it's just going to sit there for the next 3 days. Okay, so on my open countertop, we're just going to leave that jar with 50 milliliters of water right there. In our third location, we're going to travel to my laundry room. We are going to place this one, and this is the one I'm most worried about. We're going to place this 50 milliliter jar right here on the windowsill because it does receive a lot of sunlight. So keep that in mind. That is the sunniest location in my whole house. Fourth location, I think we should really cool things down, and we are going to go in my refrigerator. Okay, so here, our jar, and I'm just going to tuck it in right here next to some condiments. Oh no, I probably should have made some space. We're going to go right there. All right, so in the refrigerator, and I'll let you all know the temperature of that location as well, of all 4 of the locations. So it's only day 1. Today is Friday. I'm going to be checking back in tomorrow on Saturday and again on Sunday. Hey, 3rd grade. So we are now going to check back in on that experiment that we started on Friday. Today is Sunday. It's around 4 o'clock, so we're pretty far into our Sunday. And I labeled our jars here in order from coldest, which was our A jar, to the warmest location, our D jar. And you should have already seen the images of each one's temperature. Now, starting with our coldest, we're going to take a look and see how much of that water evaporated. Now, in the refrigerator where it was kept, it was 38 degrees Fahrenheit. Now everything freezes, water freezes around 32 degrees Fahrenheit, so 38 degrees Fahrenheit is very cold. Let's take a look and see how much water is remaining in this jar after 2 days. It's still pretty cold right out of the refrigerator. Now remember, we started with 50 milliliters. We got to get the air out and then suck up a little bit more. There we go. That's all of it. All right. Now we started with 50 and we are left we're left with about 48, because there's 45, here's 50. We can kind of round up since there's a little bit in this jar splashing around that I couldn't grab at the angle I had. So 48 milliliters is remaining here in our coldest jar, in the coldest location. We started with 50 and we're down to 48. Now in the next warmest location, which one was that? We have our B jar here, and we are moving from 38 degrees Fahrenheit to 60 degrees Fahrenheit. Now this was the one that was on my windowsill. So when I put it there originally, I thought it would be the warmest location. But this weekend we didn't get so much sun, and it was really cold and windy, and it was right beside a window. So I was surprised at how cold it was when I measured it and saw it was only 60. But it kind of makes sense with the setup of my house. There isn't a heater in that room, in the laundry room, so it was fairly cold. There we go. All right. So our next warmest location at 60 degrees Fahrenheit, we are left with 46 milliliters. 46. So not a whole lot evaporated there on the window. So we started with 50. We went down to 46. All right. In the next warmest location, jar C, and this was located on the countertop in my kitchen at 66 degrees Fahrenheit. Now, this jar, the countertop, sits right above one of my heat vents. So I thought it would be cooler than the windowsill. It turns out it was warmer after I checked the temperature every now and then. So it is one of our warmer jars, or warmer locations. And we started with 50 milliliters. And now we are down to 44 milliliters. All right, so we have a bit of a pattern here. The coldest, right, we had the most water at 48. Then the next warmest one was 60 degrees, and we had 46, right? And now we're at 44 in a room that was at 66 degrees Fahrenheit. And here we have the jar from our warmest location, which happened to be above the stove, which also something that surprised me. It was the highest location, and we did learn that heat rises because those molecules expand and they rise. So it was higher up. It was in the warmest location. It was the temperature of that location was 71 degrees Fahrenheit. Let's see the effects that had on our evaporation process here. So in our warmest location, in the cabinet above the stove, 71 degrees Fahrenheit, we are down to only 37 milliliters. 37 milliliters. All right, so that is great because it kind of proves the point of this lesson, the point of this experiment, what we were hoping to achieve. We don't have to redo it like our last one. And it's proving that the warmer the location, the more water will evaporate, and the faster it will evaporate. So thank you for participating in this experiment with me, third grade.